Coast, LA to Chicago, Western Tales. Welcome to the Two Smooth Operators Show, the only show about that gate operator life, rife. Maybe it's about both. You'll never know. Welcome your host, Michael Brooks and Robert Evers. No lead in for the show today, just me singing and doing all the stuff that I'm doing. Today, we're going to talk about gate operator fails. Pretty exciting stuff. Let me get a drink of water here real quick. That's right. You've seen them. I've seen them. We've all seen them. They're why we have service departments, and they're why we love to cuss other gate operator technicians out when it's really nobody's fault. Just things happen. Things break. We know that these gate operators aren't getting serviced on a regular basis. Do you have a scheduled service program with your company for gate operators and access control? Well, you better look at the other podcast I did the other day about getting your scheduled service program ready to go. Stop leaning on my desk here so it's not shaking around. Well, look, we're going to talk about gate operator fails. I've got some pictures of some really cool stuff that I've seen in my day-to-day doings of a gate operator technician. And I listed some of the stuff out on the promo that we sent out today on the show that we were going to do, or about the show that we were going to do. And they're really relatively simple. They're the common things that we see. And then I'm going to tell you some of the ways to help prevent them and possibly some things to look out for, especially when it comes to things that you really don't pay that much attention about because of some myths and some things that are out there that aren't necessarily true. And I love busting myths. Good H2O right there. So one of the things that we talk about on a regular basis when it comes to installing gate operators is chain. Here in the United States, chain is a little bit more popular, if not the only thing that you'll see on a regular basis as a gate technician. There are gate operators that do have drive rack systems, which is basically a big gear with teeth and a track that is mounted to the gate that fits in those teeth, and it is a solid piece, and it spins, the motor spins the gear, and the gear drives the track up and down. There are some other designs. High Security has a design in one of their slide drivers. It's more of a rail system. It's a flat piece. They finally got smart, and they actually put a groove on the bottom of that maybe 10 years ago because it was super easy just to squirt some hydraulic fluid in there, and you could literally just push the gate open if the tension was set properly or improperly. And I was going through some of my stuff in regards to chain, and this is one of the pictures that I found. And if any of you guys are interested in joining the podcast, you're more than welcome to. I'm going to put out a link on the Facebook page. Sorry, I should have had this ready, but I'm going to put out a link on the Facebook page of Two Smooth Operators. You're more than welcome to come join me, and we'll talk about gate operator stuff. I just put it up there at 5:17 p.m. and the link has now gone through. If you click on that link, I'll hear a little beep and you're able to come on in and join me if you have any questions about the topics that we're going to be covering. And today we are going to be covering, again, gate fails and how to prevent them. And we're going to be talking about change. Western Tales, you know what I'm saying? That's the kind of change that needs to happen. Two Smooth Operators is going to be talking about chain, wheels, welds, photo eyes. Actually, I don't have any pictures of any failed photo eyes, so we could just briefly cover that. If somebody puts that in the chat, we could talk about it. A lot of things have changed with photo eyes because of DC gate operators. They are running a lot smoother. So whereas before we couldn't mount photo eyes to anything having to do with the gate operator, nowadays we can because the vibration is a lot less. And most of the gate operators that were AC in the United States, they would vibrate a lot, especially if they had belts and not direct connect to the gear reducer. So getting past that, don't really have much on photo eyes, hinges, which I spelled wrong on the little post that we put out, and physical stops. So in regards to chain, this one's going to kind of be tough if you're not looking at it on your desktop. We're going to take a look at this exact same gear and this exact same chain, which is some 50 chain on a swing gate operator upper gear reducer. And if you were to take a look at it closely and you have experienced this before, you would notice in the valley between the teeth that there's a significant amount of wear. And what it is also doing is wearing the roller of the chain at the same time. And that, in essence, will start to make the distance in between the lowest point in the valley further and further apart. And as it does that, in this case, it didn't happen because one is a 50 chain. The teeth are a lot taller, so they haven't had a chance to wear down yet. And the way that this chain is there's not much potential for slack in it. So it actually is not going to most likely skip. But what is going to happen is at some point in time, one of these teeth is going to break, and that will cause us to have some skippage or some alignment issues, or just in the function of it, you will hear some clicks and clacks and some grinding that is always cause for concern when you're dealing with chain. So just looking at this, I can see that the valleys are going to be a lot lower because on one of these teeth, I can see that it's rounded at the bottom of that valley deeper than it should be. However, in this particular case, if you were to inspect the chain a little bit further, you would also notice that it has worn in more than one position. Most likely, this is due to one, just overall life. In this particular gate operator, I don't think that the manufacturer recommends any kind of lubrication for it. So you're really just letting it wear as much as you can. And I'm not sure why they don't recommend lubricating it, but I'm sure there's a reason for it. Maybe it slips, has something to do with this one has a clutch on it as well too. So maybe it has to do with the adjustment of the clutch. But if you'll take a look closer, now that we have a little bit of a close-up, let's see if we can make it bigger. No, it's still the same size, so you might as well look at my ugly face at the same time. Look at that, bam, bam. So you can tell that the chain has actually worn a groove of the outer figure 8 on there into the gear. The amount of time and pressure that it takes to do that is tremendous. So this gate operator is most likely 20 years old. By now, it could even be older than that if they haven't replaced it. And when you see this in something other than a 50 chain, it is immediate replacement. And we're going to look at a smaller gear here in a minute, that we had service call on. Customer could not figure out why. It would stop short one time and then go too far the next time, and so on. And that has to do with these gate operators that are using that chain and drive gear system to determine the position of fully open and fully closed on the gate. Now, this particular chain, I wouldn't lubricate it because, again, the manufacturer doesn't recommend it, and most likely it has something to do with that clutch. So I'm just going to let it wear and keep an eye on it. However, from a scheduled service or from a service standpoint, as soon as you see that, you have to keep in mind, I'll just replace the gear. Well, if you do that, understand that the spacing between the rollers on that chain has now worn to the same valleys that are in that gear, and you're going to just cause more problems by changing the gear without changing the chain. And that's the key thing that I want you to get out of this is when you see wear on a gear or a chain like that, you don't replace one without replacing the other. In a drive chain, and again, this chain is going from the upper gear reducer to the lower gear reducer on an Elite CSW 200, you don't have that much slack in there. So the likelihood of it skipping a tooth or something along those lines is less likely than on a drive chain. And in that scenario, you're going to find where you replace the chain and don't replace the drive gear, or replace the drive gear and don't replace the chain, and you will immediately hear as the actual chain, as the gate operator is opening and closing. And what's happening is possibly it's slipping a tooth. And if it were a new gear, that either way, if it's new chain, old gear, or new gear, old chain, it could be that, but it could just possibly be one, because you just replaced everything. Now you've tightened it back up. It's trying to figure out where that alignment is. That spacing in between the teeth, therefore in between the rollers of the chain, is a finite spacing. And when you start to mess with that, you also start to mess with the positioning of the gate. So let me show you this picture real quick, and maybe it'll make it a tad bit clearer. So on the orientation that I'm looking at, on the right-hand side of the screen, you can see that black chain has a little silver part to it. Well, that silver part is fresh metal, and it has worn a groove into this gear. Now, this is a limit gear for an Elite SL3000 slide gate operator, and these gears are a little bit smaller, and the chain's a little bit smaller. Actually, I don't even know what size chain it is, but it has a tremendous amount of stress on it when it is not properly aligned. The gate operator gets hit. The chain has started to wear. The drive gear for the limit assembly has started to wear, or the alignment has got out of place, which I bet is what's happened here. The alignment of the chain and that top gear and that bottom gear need to be perfect so there is not uneven wear. And when you start on that uneven wear, the hardest metal is going to wear down the softest metal, and you're going to have scenarios like this. And the cause that you'll see, especially when it has to do with any part of the drive system, is that you will see that the gate opens too far, closes too far, or doesn't close far enough, or doesn't open far enough, and you'll see generally the reciprocal of that. But I want you to be listening and looking at it as well too. Underneath this, it's quite possible you might see some shavings. Visually, if you can't catch it by the teeth and the chain, that could be one thing that you need to take a look at when you're doing scheduled service. The first thing that my ears would perk up is that the gate is getting stuck open, or the gate is getting stuck closed, or the gate is not closing as far as it did before, or it's not opening as far as it did before, especially when you hear about somebody just serviced it and now it's doing the same thing. What most likely has happened is, and this is weird because it can happen only in one direction and correct itself in the other direction, is that the teeth on the gear have worn down significantly enough that the tension on the chain will allow it to slip over. And when it does that, it gets out of position and it won't close far enough or try to close too far. And in certain circumstances, when the gate being stuck open or stuck closed, is that it has now got out of position. It has hit a physical stop. I'm saying physical stop, but anything physical, that whether it's intended to be a physical stop or not. Physical stop typically when we refer to that in a gate operator, is something that the gate operator technician has created to prevent the gate from doing an action, generally going too far too far on the track and creating a scenario where it could fall over. But there could be, it could actually hit something. For instance, the chain could pull up in the idler wheels up through the drive sprocket and down and pull back far enough to where it stops, but it actually doesn't hit a physical stop. So what's happening when you actually get a call that, hey, the gate is stuck open or stuck closed, and in this particular situation, it could be that the gear has worn so much and it has now got out of position and gone too far in one direction. And you can take the temperature of the motor. I always recommend using a non-contact device in order to take the temperature of the motor as opposed to your hand. Our hands can't tell the difference between 150 degrees and 250 degrees, but regardless of whether it can tell the difference so you can get an accurate reading, you don't want to touch something that's that hot. So if you take your non-contact IR temperature gun or thermal imager and take a look at what the temperature of the motor is prior to actually putting your hands on it, that might also be an indication that the motor has now overheated and tripped the thermal protection switch if it has one. A lot of DC motors these days won't have a thermal protection switch where you can physically reset, but you could have to where it actually shuts down electronically prior to that thermal switch or thermal protection tripping. But in an AC motor, it was very common for you to walk up, the gate's all the way open, the gate's all the way closed. Let's say the gate's open to the right and it's all the way open, and you walk up to the front part of the chain and you pull on it and it's tight as a drum. That's a good indication that this chain and that gear, or a gear and a chain, have worn so much that it's now slipped. It doesn't know that it's not supposed to keep going, keeps going. The sensitivity does not recognize that it's hit an obstruction, continues to push, and then all of a sudden it gets so hot that the thermal protection trips. So when you see a motor, when you see a chain like this, those could be symptoms of a fault in this case, and this can happen on a limit chain and limit gear or a drive chain and drive gear. There are a lot of things that when it happens that you might be able to catch right off the bat, but as service technicians, as installers, we don't get to see it right when it's happening. Luckily, if you were there, you could see it. But generally, we're getting called because of something that's already happened in the past. And then we got to be Inspector Clouseau to try to figure this crap out from the limited details that you got. So what I'm telling you are things that you need to be thinking about when you get that phone call, because there's other things that you could possibly observe. You know, you say you can't see the forest through the trees. If you are driving up to the gate and you look at some of these other things, you might be able to see that, if there is no gap on the latch post and the gate whatsoever, so that thing's pressed right up against it. The tension on the chain is something that you look at when you get out of your truck, but this could be something that you could also observe some stuff from before you get to the actual gate in your truck. The other thing is, as you're walking up to it, you can actually use your other senses. We talked about touch. I don't want you to touch the motor until we are 100% sure that the power's been turned off and that we know that the temperature is not in excess to where it'll actually burn it. When you get that close, you can also use your snout to see if there is any burning smell inside the gate operator or around that area. Now, most likely won't come from the chain as far as the burning smell. It will come from a belt that has been turning on one side and on the other side has had the pulley or the gear preventing it or physically stopped, and that belt is just continuing to go, and it'll give off a burning rubber smell. The other thing that you can see when that happens is that you'll see black fine dust. and that black fine dust is the actual belt that has been wearing. Now, the thing that I always tell people, and maybe you can't do that when it's like a limit chain or something like this, and I think we're kind of getting away from those nowadays, now that we're going DC direct to the gear reducer. We won't see these types of smaller chains on gate operators, but all of this still applies to drive chains that go between two devices that aren't the limit assembly, like the heavier chain, like this chain that I was just showing you for guys that are just now popping in. This chain right here had some wear on the gear that you can see. And then if you're astute to chains, you can see that the valley in this sprocket is significantly worn enough without even seeing that other, because these are the same gear. But you can see in this picture that it's worn significantly enough to cause concern where you need to replace the chain and all of that stuff. So that stuff still applies. However, this is always really the test that I tell everybody. If you can't pick that chain up and on both sides it fall down, then we know we have a problem. And this is actually what it'll look like. You might think that this picture was taken like this for dramatic effect, and it was posed like that so we could be like, oh cool, that's a cool chain. Well, no, it was taken a picture. I took a picture of it like that to show that this chain is not moving whatsoever. Okay, it is not moving at all, and it is so stiff and so rusted that it will hold that position. You can look at this chain and see other spots in the chain physically to where the figure eights are actually out of alignment and where they should be straight. It should be following it, but it has so much resistance just due to rust and wear that it can't even collapse on itself when it's stuck up like that. So when you see something like that at any part in the chain, then it's time to determine whether you're going to replace the chain. And what else do we replace when we replace the chain? We just talked about it. All three of you listening. If you replace the chain that has significant wear on it, you also need to replace the gear as well too. The chain and the gear wear together. All right. The softer material is going to wear first, but in chains and drive sprockets, these are generally the same, if you will, grade of steel. I'm sure one's softer than the other. Who knows? But that spacing in between the teeth of the sprocket and the spacing in between the rollers of the chain wear at the same pace. And the last thing that you want to do is replace a chain and have it on an old gear. And then as soon as you go to run that gate operator, you hear that noise that I was talking about before, that, and then it rolls another foot, rolls another couple feet, or if it's bad enough, it'll just make that damn sound the whole time. And you're like, hold on, is my chain not in alignment? Well, I mean, the chain bracket is 10 feet away, the chain bracket's 10 feet away, and it's still making that noise. Well, it very well could be that the alignment in between the rollers and the sprockets, the sprocket teeth, are out of are not the same, so therefore it makes that grinding sound, and you'll notice it. You'll just think that, hey, you'll think that it's some other part. That's how bad it will be, because you just replaced the chain. So it can't be the chain. Well, you got to think of the drive gear as well too. So you have to replace both at the same time. The last thing I wanted to talk about chain is too, you have to keep in mind the cost of your labor going into replacing a small section. If you have a small section, that's bad because it's damaged or somehow it wore faster than the rest of the chain, but the rest of the chain's still good. You got to keep in mind that maybe it feels good, but you know that it started to wear at the same pace that the other one did. But maybe that other part of the chain, the last 2 feet or the first 2 feet or something like that, is wearing because it's not covered or it's by a sprinkler head or something like that. And those are things that you need to address as well too. However, if you're going to replace 2 foot of section, just break the whole chain out, break a whole new chain out and put a new chain on there. And if the master links look worn, replace the master links, replace the chain bolts, and replace that drive gear if this is the type of issue. Because you will find just that small amount of labor that you're going to put into that will save you and the customer the gate being down in the future, as well as having to come back out. This particular chain was an hour and a half from where my office was, and I was not going to take any chances with it. So I just replaced the whole chain and then called it a day. Now, there is a little bit of a caveat to if one part of this chain is like that, then replace the whole thing. It is what I mentioned just about a couple of minutes ago, that the chain that goes from the chain bracket to the front part of the idler wheel that never goes under the idler wheel or idler gear, over the drive sprocket, and then back over under the other part of the idler wheel, technically could be a solid piece of steel. So it could be rusted all to hell and still work just fine because it never has to make any kind of curve or anything like that. Now, being a solid piece of steel is exaggeration, but we do have that happen all the time because sometimes we put chain bolts on there that are 10 inches long or longer than that. When you've got a 50 or 60 or 70 foot gate, you'll put a longer chain bolt on there so one person can actually still get the chain bolt on there. So replace part of the chain, think about what it would cost just to replace the whole chain. Then they got a brand new chain. If you're not going to replace the drive gear and chain at the same time, you're just asking for trouble. So just keep that in mind. The other thing is too is, and I know we're spending a lot of time on chain. If this is your chain right here, right, and it's in the orientation where the holes are pointed up, just like you see in this picture, you want to lubricate from here to front. You want to lubricate this direction, that direction on the bottom, and that direction and this direction on top. There is a way to do that efficiently. I'm not going to tell you what it is because it's really for an experienced technician to do. And you have to take precautions a certain way. So far we've only talked about chain, but some of the stuff that we're talking about as far as lubrication and alignment, it's actually going to fall into some of this other stuff too. So a lot of stuff was important when you're talking about replacing just one piece and not replacing the other. You got to remember those bad pieces are wearing into, if you will, the good pieces, or vice versa. And if you're going to replace one part, you might want to think about how that affects the alignment, positioning, and function of the other parts. So that pretty much covers chain. You just replace the chain and the drive sprocket at the same time, and then just make sure it's regularly lubricated. I get people ask me all the time, like, how often should we lubricate the chain? If it looks wet, it is wet, and it needs to be wet in order to be, when it's lubricated, it's wet. So if it looks wet, it is wet, is kind of like my theory. It's not generally something that I recommend the end user do, but I'm pretty sure most manufacturers' manuals have it in there as regular scheduled maintenance and says, hey, you have to have a professional technician work on it. So I would be cautious about having the end user do it, even though I have some people that do. I can't, you can't stop somebody from doing that. So would you guys consider this a bad V-groove wheel or not? Because this thing is hit. I didn't even, this is one of those things. Oh, and by the way, this was on a working gate operator. They had this thing going like this for some time. I mean, obviously it doesn't fail like that, right? It wears like that. And then eventually they're just like, what's that noise? And then they call me, and then you're like, yeah, you need to replace this. So a couple of tips about wheels and boxes. So with wheels, and by the way, add in the comments if anybody's got any questions or anything like that, and down in the chat, I'd be more than happy to respond to them and pull them up. Wheels. So first of all, you need to make sure that you get the right wheel. And when I say the right wheel, meaning for that application, and it doesn't always necessarily mean the most expensive wheel either. Sealed bearing wheels and brand name sealed bearing wheels are generally more expensive than what this wheel was, a cast iron wheel. They are generally made out of one or two pieces of steel that are galvanized or zinc plated or coated and then welded together, or they're just made out of one solid piece and it is ran through a CNC machine. And their weight rating is 5 times of the exact same size wheel in the casted wheel like this. So these wheels, in my opinion, have functions in commercial situations where you have high traffic areas as long as they're serviced. A cast iron wheel is not something I would generally go to in a apartment complex, HOA community with a bunch of homes. Of course, apartment complex with a bunch of homes as well too. So basically high traffic areas. I typically will stay away from a cast iron wheel. And the reason is not because it's a lower quality, even though the weight rating is a little bit lower, the quality is what the quality is. You're getting exactly what you pay for, even when you get these Chinese made wheels, which are generally a little bit less expensive, but the quality is significant for commercial applications. But I like putting a cast iron wheel when cost is an issue, and I know that there's not a high traffic area. This particular one wasn't a very high traffic area. However, it was a sensitive area. This one went to an airport, and I would just like, I'm not putting whatever the cheapest is. I got to put what the most expensive, or I shouldn't say expensive, that didn't really have a factor into it, but they do play off each other. What the most durable, reliable, consistent one is, that is maintenance free, because these guys were only servicing their gate operator at first when it broke. And then when I told them that they needed to do scheduled service on it, and they didn't realize that there was a program for that, because at an airport, when you have direct access to the runway, they don't play around with that. You have to get that gate closed ASAP, even if that means physically taking the gate over in the closed position and bolting it to the gate, even though it's not attached to anything. You got to make sure that there's nobody getting in and out of the airport runway. So anyways, this particular one, they never serviced it. So I recommend going in with a sealed bearing wheel. Now, there's a little bit of misnomer. It's kind of like a sealed battery. Sealed batteries aren't sealed, and sealed bearing wheels aren't sealed either. It's just a marketing term and an industry term that they use, meaning that it has a cap on it and it's maintenance free, and there is no maintenance that needs to be done to it in order to get the life that they say that they're going to get out of it. So in a sealed bearing wheel, because it's not sealed, the reason why I would go with a cast iron wheel as opposed to a sealed bearing wheel is if they were aware that they had to regularly maintenance it, and it was in a channel where the wheel was going to be sitting under water or close to dirt and debris where water could get into the wheel. In those applications where I have sealed bearing wheels and it's sitting in water and dirt and debris when it's in the open or closed position, they don't last as long. So that's why I like these types of wheels, because it's hard to see in this picture, but there is a nipple on the end of the bolt, and there's also a nipple that's on the wheel, and I can lubricate those with a hard grease and a solid grease. A solid grease is going to do everything it can, just physically, even immersed in water, to keep that water from rusting the inside. So in those types of applications, I will choose a less expensive wheel, knowing that the customer has to service it. In this case, where this wheel was, I had to replace the box and everything. This is not a box that you go out of your way to try to save. But based on what I see here, and now that I remember, I think I did try to save this box. That's why it's like split in half as well too. Just take your grinder or Sawzall, just cut it all the way off, put a new box, new wheel on, call it a day, get it aligned and all that stuff. So this is an example of probably the worst wheel. So you want to make sure that you get wheels for the right weight rating and right usage. This is a sealed bearing wheel, and this was an example of where it was in the wrong place, where it had dirt and debris surrounding it all the time. Now, I have never seen a wheel do this, which it had like folded over on itself. It was still functioning, but it had folded over on itself. And these little grooves that you see in here, they had actually worn a half moon shape into the box that it sat in. So the box that it sat in had almost knocked that whole thing out. So when I got to the gate operator, I had to tap it back in with a hammer and then tack weld it back over. And it was 50-50 on replacing the box or not, but I knew my weld was going to be stronger than the box. So I just went ahead and welded it, and that one worked out fine. So these do not need to be lubricated, but even though they're called a sealed bearing wheel, they are not sealed like you can put them underwater and they won't get water in there. You could take that little gasket, just pop it off with a screwdriver, so it's not like it's impregnable. It can be penetrated with water. So tips about wheels real quick. With the installation of the wheel, it's going to be kind of hard to demonstrate. So I just want to tell you about it so you know when you're going to install a wheel. The size of the wheel, not only to the diameter, but the width needs to be matched to the box or the bracket that it's going to go in. These wheels are made to where they push pressure on that center collar, and that center collar stays still so it doesn't roll on the actual bolt that you see sitting next to it. If it rolls on the bolt, it's completely against the design that it has. It's not rolling on the bearings on the inside. It's just the friction between that collar and the bolt. So if you don't have the proper size box, you can never get the appropriate tension on that wheel to prevent the collar from slipping and then wearing out the bolt. So you need to make sure that all of those things match when you go do it. These wheels don't need to be serviced, so there's nothing you really have to do. And in most applications, 99% of them, these are perfect. But when you get that wheel in the back of a trough, it's not so hot. So the other thing we wanted to talk about welds, I saw this picture. I just pulled this up. You can see it has a piece of broken aluminum. This was a brand new barrier arm, and got hit by a car, and it just cracked this piece of material. It didn't crack on the weld, so the weld was fine, but the material was soft enough to where it actually ripped the material out. It could be a combination of where it was hit and how it hit, and then how we had it bolted to the stand that it was on that caused it to tweak and rip like that. So it wasn't a failure because of the quality of the product. I just thought it was interesting to show you what happens when two pieces of metal rip apart. That was on a LiftMaster barrier arm. Now, bad welds. So with welding, I'm not a weld expert, but I have been doing it for a long time, so I know what to look for. And some of this stuff for you guys that are salespeople, superintendents, managers, general managers, GCs, and so on, that's one of the things that's helping you guys out, is understanding what to look for. And although I don't have a bunch of examples of good and bad, I just actually have this one bad one. It's the only one that I could find, even though I see it all the time. This, I don't know what the cause of it was. Some of this looks bad down here on the bottom just because the paint probably wasn't applied right, and therefore it started to peel off or break off or whatever. And then now that this water's coming down, it's starting to leave this white residue, whether it's corrosion or whatever it is. But this is an example, in my opinion, again, I'm not an expert welder, of something happening with the position of the stick as they were welding, as well as the temperature. A lot of people would see this, they'd call it a cat shit weld because that's what it looks like, or bubblegum weld, one of the two. Because that's what it looks like. It looks like it's just clomped on there. Sometimes they call bubblegum weld just because it sticks on there, but it's ready to fall off as soon as the bubblegum is no longer sticky. But this is an example of not that it didn't have enough heat. It just didn't look like that they were using the correct motion of the stick when they were trying to create a weld bead down this piece of material. The reason why I'm pretty sure that they had it hot enough is because the steel that is welded to the post, it is penetrated significantly, almost so that they probably had to do a lot more work than what they were needing, because they were finding that part was melting away quicker than they could actually get it to adhere to the actual post. And this is a thin wall post as well too, so maybe they were spending more time on the thicker metal than they were on the thinner metal, which is what you would do when you are welding two pieces of steel or two pieces of material that have varying thickness. Sometimes you'll spend more time getting the thicker part hotter than you will the thinner part. So when you see something like this, it's cause for concern. In this particular case, they bolted they welded the bracket to the post, but then they bolted all the pieces for the arm without putting a little tack weld on them. Me personally, I would just use the bolts to get my positioning, and then I would weld all that stuff on there, which is what we ended up doing for this. Now, does that make it serviceable? No, but neither's 99% of the other welds that you are going to do on gate operator actuator arms, the pivot arms for them. You're going to burn them into the steel, and you don't want them to move. And not necessarily that you don't want them serviceable, but you're going to have to cut that whole thing off to make it serviceable. So that's an example of a shitty weld. A couple of things with welding. First of all, make sure your material is clean as can be. So that means that you'll use a wire brush or a flat disc to clean the material that you're welding to, and clean the material that you're welding onto it. Having a good ground is probably what I see the biggest issue in most people's welding, that they don't take the time to actually brush a piece of the steel paint away from what they're welding to for the ground. They clean everything else, but they don't get a good ground. And you need that electricity to flow from the ground all the way up to the gun, depending upon what type of weld you're doing. Sometimes electricity flows from the gun or the stick down to the ground, or sometimes vice versa. None of that matters. What I'm showing you is what to look for. And then the other thing is proper penetration. The welder that I use is a Miller-Matic 140, and it is a MIG or mag welder that uses a gun and a trigger, and wire comes out the end of it. However, the 140, being a 120 volt welder of this caliber and duty cycle, it is not made to penetrate past 3/16. So I weld 1/4 inch all of the time. Well, that's kind of a misnomer. I'll tell you why. I weld 1/4 inch and 5/16 all the time. So how do I get away with that if I'm welding two 5/16 pieces of steel together? Well, you have to cut down the material. I think they call it chamfer it. You have to cut down the material, and you have to lay multiple beads on top of each other in order to get it to weld right. The other thing that you could also do is put a weld on the top and the bottom, and that cuts, if you will, the thickness down, but you're still chamfering the steel. The newer millers of that same caliber will do 220 and 120, 240 and 120, and I think they're rated up to 5/16 at a 20% duty cycle. So that is a common thing that I have because I always run off shore power meaning the power that's coming from the utility, generally off the building. A lot of gate operator technicians will not do that whatsoever. They have a welder with a generator on their truck, and therefore power is not an issue most of the time. And they don't have to worry about the proper penetration. I do, and I take steps to make sure that I get proper penetration, because I don't want to come back if the weld fails, but more importantly, I don't want a weld to fail and hurt the technician or hurt the end user. The one thing that I don't do is when I'm using 7-inch barrel hinges or a 7-inch J-bolt hinge or something along those lines, that I will use won't chamfer the pads or anything like that. That I will have a stronger, if you will, higher voltage welder weld on that, or higher current welder in that case weld on that. So again, I'm not a professional welder, just some tips that I see out there. As far as hinges go, I don't really have any good examples other than that right there. It looks like some good welds on there. But when you're inspecting hinges, just make sure that you see any things like this, like a missing bolt or anything like that, that can affect the alignment. You have mag locks, you have an arm that doesn't have very much flexibility that's connected to it. It can cause all kinds of havoc. So wish I had some better pictures for hinges, but hinges, same thing. Appropriate hinges, making sure that they're aligned properly. 3 hinges in general is a no-no. And lubrication. Your gate should move, and I'm not putting any restrictions on weight on it. Your gate should move just by walking up to it, pressing it, and leading into it. From the completely open position to the completely closed position. All right. No ifs, ands, or buts. If you feel any resistance, you need to address that. But the most important part I'm trying to tell you is you need to push that gate or swing that gate all the way to the fully open position and all the way to the fully closed position, and do it multiple times to make sure there isn't a significant amount of resistance, because there's some tricks for young players, traps for young players in there. If you're not doing that and doing it multiple times, you're going to find out that these problems that can be addressed right away, such as a bad roller or a bad I forgot what you call them, but it's a little piece that holds on the roller, like on a pipe track. One of those things gets out of alignment, and for whatever reason, you're not pushing it, or you're not seeing it in the first 1 or 2 cycles, and it pops up in the 3rd or 4th one. It's going to make you go down a different path than where you need to go. So you need to push the gate all the way open, all the way closed, multiple times to make sure that your hinges have zero resistance in them. And it's really important at the last part of that movement on both directions, because sometimes that's where it'll show its ass, and you'll have it to where it's just out of position and you get it all the way open, and the last foot or so is where it has resistance. And you're like, well, that's not that big a deal. It is a crucially big deal, because if you're doing an articulating arm or actuator arm or any type of swing type of arm, most of the time, the most stress is being put on that motor, and the last part of the open, last part of the close. So that last part of it is as crucial, if not more crucial, because of what the motor sees, and you need to make sure you open it and close it all the way to make sure that there's actually no physical resistance. So we're going to talk about physical stops. So I pulled this picture up and wanted to point out a couple of things. Overkill on your physical stops. These tragic accidents that are happening, and where the manual gate, which is where a lot of a lot of deaths have happened, not automatic gates. Unfortunately, we're all lumped together. The manual gates have you put a 200-pound, 100-pound chain link gate up. You're like, oh, I could just put an eighth of an inch piece of steel to physically stop it from going off here or here. Just save yourself the hassle. Get you a thick physical stop, weld it on there, call it a day, because it is going to rust. It is going to wear. And if you have a good 5/16, 3/8, half-inch piece of steel on there, even if it rusts, but the weld's still good, the rust will have a protective layer on there, regardless of whether the paint's still good, and it will most likely survive without weakening to the point where you can bend it and the gate goes off the track and falls over and, God forbid, hurts somebody or hurts a gate technician, which gate technicians are 937% more likely to be hurt by a gate than the end user. And I got the hands to prove it, and scars on my face to prove it as well too. But we don't want anybody to get hurt. I have yet to meet the gate technician that goes, I'm going to go out and put a gate operator in today that's going to hurt somebody. I've never met that guy. And although I would never rat on somebody that's not doing the down and dirty, oh, you should have tightened that bolt, 2 turns as opposed to a turn and a half or whatever. If it's not creating something that's unsafe or unethical, it's not my position to rat somebody out. But you do have to keep in mind that people are going to be using these gates past you, so including technicians like yourself. So do yourself a favor, help protect everybody, and keep that mindset that it's easier just to pull a chain bracket off, just cut it to fit the track, weld that thing on there, and that's 10 times better than any 1/8 inch or 1/4 inch piece of strap that you're gonna put on there. So overkill on the physical stops. Make sure that but I would highly recommend having something that's stainless or zinc coated or something like that, that will help protect that device from rusting, the actual physical piece from rusting. And then now you're just relying on your weld. And as long as your weld and the material that it's welded to is good, you're in good shape. But having something that's stainless, zinc coated, like an L bracket or something that for a unistrut will eliminate one of those 3 things: the material that it's welded to, your weld, and then the material that you're welding. So just do a little bit of overkill, save yourself the time. And then even though it's on the track, sometimes you weld stuff to the V-track, or maybe some places not going to see, just brush it and paint it real quick so we can make sure that weld has the longest life as possible. And then the last thing, it wasn't on the list of things that we were going to talk about, was electrical. Now, as a gate technician, these are our favorite things, right? We're just like, oh crap, well, let's just replace the $700 board and move on to the next one. And sometimes it's that simple. In areas where you have a lot of lightning, Texas has a lot of lightning. Where Robert lives, there's a lot of lightning, and he deals with stuff on a regular basis that's directly related to lightning strikes. Surge protectors help with manufacturer's recommendations, but grounding helps as well too. So most manufacturers of gate operators and access control have specifications for what you need to do with grounding, sometimes bonding, and ground rod. So we will find more ground rods on the gate operator stuff than you'll find on the interior access control stuff directly relating to you installing them. There's still going to be some kind of earth ground connection, whether through bonding or grounding the material or grounding the equipment itself. But gate operators, so if you have the right equipment, and depending upon what part of the world you are, right now I'm in Nevada, I'm still going to offer ground rods to people. However, it's going to be 4 times as much because of the expense to do a ground rod. This ground is different than where you will find the conductivity or resistivity of the ground here as opposed to in Texas. Is just completely different, which brings up another interesting point as a side note. When people are talking about, well, UL or ASTMs in the International Building Code, municipalities can do whatever they want with that. And if you look in the NEC, the National Electric Code, Nevada and Clark County have done just that. Changed shit in there that if you're not aware of, doing it in Texas or doing it in California is completely different here because of the conditions and the people, the authority having jurisdiction, recognizing that and making those changes. So that's just a side note as far as these blanket things that people are talking about, like, oh, that's not the code, that's not this. Well, code and amendments to the code and the adoptions of which code they've adopted are completely different things. So just keep in mind, you still want to do this in respect to the authority having jurisdiction. So ground rods, way I used to offer them was a $400 option per device that we were actually installing. And sometimes, depending upon the location of some, you could get away with 2 devices on one ground. But what you don't want to do is you don't want to change the resistivity from the device that you're grounding to the ground rod by having one ground over here and one device over here and grounding both of those devices to it, because the resistance now has changed in that ground. And when you have 2 different potentials, you have voltage. So I see people talking about this stuff all the time about, this is a little bit side note from the ground rod, grounding your data wire on both gate operators. Well, if the potential of both of those gate operators is different and that can change. I mean, at any point in time, the irrigation on that side of the gate operator to the irrigation on that side of the gate operator can change the resistivity. And when you have data in between both of them, now you're talking about a potential corruption of that data. So, oh, why doesn't my secondary gate open? Well, that could be an example why, because it's not getting the appropriate data. Going back now, that is tying a shield into chassis ground for the devices that you're connecting to. And 9 times out of 10, you'll just tie in one of the shields. But I see people talk about that all the time, unless the manufacturer specifically says that, because maybe they've taken advantage of a primary secondary cable that's going between them, and that creates the potential to be the same on both gate operators. So make sure you're doing it within manufacturer specifications. Let's go back to ground rods. I always offer these as an option to my customers. And in Dallas, we could do it in 30 minutes or so. And then we had approximately about $40 in material, plus the labor and then the special parts to make sure that that labor is cut down to next to nothing. We didn't prep the ground. We wouldn't put any rock or any special material around the ground rod. We would just drive it in, because again, the resistivity of the ground around the ground rod was sufficient enough to do what it was doing, which was helping some of the stray voltage that could come close to the gate operator dissipate and go back wherever the ground was going to the panel. But because I'm not a grounding and bonding expert, you always want to check with the authority having jurisdiction, and also you want to check with you want to check with whatever the manufacturer's specifications are, because they may have experienced in different parts of the world that you can do certain things here but not here. So we would drive a ground rod in as deep as we could get it, and drive an 8-foot or 10-foot, I can't even remember now. We had a specific part number we would use. It wasn't a 5/8 one, it was the next step down, which I think is a 3/8. Then we would take ground wire, a conductor with a fitting on there, take that fitting and do to the negative part of the battery or wherever the manufacturer recommended the ground be. Now, grounding equipment doesn't prevent what you actually see here. which is most likely a stray voltage from an electric strike that got on one of these wires to it and blew it up. Now, the reason why I'm somewhat confident in saying that that's what happened is because we put a new control board in and the gate operator just worked. So if there were a malfunctioning part that were happening inside the gate operator, so that would be the motor, the electrical, or whatever, either we fixed it by making a new connection, or it was not an issue ever to begin with, and this was just some stray voltage that came from somewhere. It very well could have been an electrician's mistake, where it could have been backfeeding into the circuit. It could have been a number of things, somebody switching over a panel and accidentally connecting 240 to it. Whatever it was, ground rods aren't going to fix that. The resistivity of the ground at a foot away from the gate operator is not what would be short circuit protection. It's not there. There's too much resistance in between the ground and the power source, which is typically the transformer from the utility company, for it to actually be a ground protection for your body. So you have to keep in mind that just putting a ground rod in there doesn't make it double safe. One, you could cause issues depending upon how the manufacturer has their equipment specified, but it is not 9 times out of 10, 99 times out of 100, it is not sufficient enough for it to be protection for any stray currents that go through your body. It is not. There's just, unfortunately, the resistivity of the earth doesn't have enough parallel pass at that gate operator at the ground in order to be able to go back to wherever the source is, which most likely, it's not the breaker panel, it's the transformer on the pole or down on the ground. So putting in ground rods to the manufacturer's specification, to the authority having jurisdiction specification for wherever you're at is a good thing. I've been in many of classes where people are like, no, they just attract electricity, blah, blah, blah. If you want to believe that, go ahead. It's not how I was trained as a radio operator. It's not how I was trained as electronic and electrical technician. So you figure that one out for yourself. So put ground rods in, do earth grounding to them from the chassis, whatever the manufacturer specification is. And then also make sure if you're bringing anything into it and you're anticipating that it's going to be a good ground path for you, that it actually is. So when you're bonding something to a gate operator, like off of the building, off of pipes or whatever it is that is then grounded itself, you better damn make sure that the one, you're allowed to do that, and two, that you're actually properly doing that. There are some things, some flexible metallic conduit and stuff like that, that may not be a good return to ground. And you could not only be causing a hazard to the equipment, you could be causing a hazard to the technician or the end user. So you got to be careful with that. So this is most likely stray voltage and electrical issues. Those are some things that I just want you to keep in mind. When you are tying in a shield to two different devices, you may not need to tie it into that second device. But if there is a potential difference there, not immediately, just electrically, potential difference means voltage. So now you've actually created voltage on something that was supposed to drain voltage, the shield, sometimes called the drain voltage, and now you've created voltage and you could potentially corrupt that data. Now, if it's a gate operator primary, secondary, hopefully in the software, they say the software says, when I lose communication with a device that has all the safety devices connect to it, go ahead and stop. But we know older designs don't necessarily have that. They'll keep going till the next cycle. They don't give that command to tell it to stop. They just say, okay, no more communication. Just do whatever you were going to do without us. So you want to make sure that when you're shielding a wire, that you're doing it properly. And that does not mean shielding it to both devices. Ground rods, you want to do whatever the authority having jurisdiction says. You want to do whatever the manufacturer says. I always recommend putting in a ground rod. Not only for when something happens like this, like a board, blows up maybe a day after you install it, you cover your ass by saying, well, at least I offered it to you, which still they're going to complain if it blows up a day afterwards anyway. But you have the ability to make that equipment a little less prone to these types of electrical shocks, if in fact that's what this was, and protect the equipment to give it a longer life. I will tell you this, that the longest life access control outside telephone entries and gate operators that I have seen out there do have ground rods. It's just the way that it is. I've seen telephone entries last for 25 years. I mean, some of the first control boards that the company ever made in these telephone entries, and they've got ground rods. So I'm of the opinion, based on performance, but forget that, based on the scientific outcome of what a ground rod does, to put ground rods in. Have we beat that one to death? And when you see a transformer that looks like this, just replace it, even though it's working. I put that transformer back in and I was happy with it. And then I got a new transformer and came back out and swapped it, but it was still working. It had just overheated. It had overheated so much that it had melt the outside of the plastic. And this was one where it didn't have a resettable fuse or a fuse that you could actually get to. A lot of transformers do have fuses inside them, but you can't get to them. So what's the point? Maybe there's some protection or something like that helps with stray voltage and you getting electrocuted or whatever the case may be. So that's it. That's what some gate operator fails that can happen. And those are some ways to protect it. Just recap real quick. Chain, if you're replacing the chain, replace the drive sprocket. They wear together. Don't replace one without the other. If there is a bent link, you need to be able to determine whether you can justify just replacing the 1 foot or replacing the whole chain and the drive sprocket. My opinion is it's very rarely the case that you just replace just 2 feet of it. If that 2 feet has gone bad due to non-maintenance, just replace the whole thing, replace the drive gear. You need to replace them both at the same time because they wear at the same time. Wheels, you need to make sure that you're matching the appropriate size wheel to the demand that it has. Sealed bearing wheels aren't always the right thing. If they're going to be in dirt, debris, leaves, water, I would much rather have a cast iron wheel, provided it was the proper size, match the usage that it's going on. Much rather have a cast iron wheel or a non-sealed bearing wheel, regardless of whether it's cast iron or not. But typically in our industry, all the non-sealed bearing wheels are all cast iron. I'd much rather have that in that application. Majority of the time, high traffic areas, I'm going with the sealed bearing wheel. I just can't have those sitting in water and expecting them to last. When you see something like this, run. Weld's relatively simple. It takes a professional to do it. Some of the tips that I got for welding, just make sure that you have a good ground. A lot of people won't take the time to actually brush the steel material that they're welding to and put their ground on it. And just chip some paint off and that's it. Can affect your penetration, affect the quality of your weld, and so on. Make sure you clean the material that you're welding to and clean the material that you are welding and get proper penetration by using the correct equipment. Like I said, I use a 120 volt welder that hooks up to shore power, and I have to chamfer the ends of the steel in order to put a couple beads across it when I get past 3/16 or don't have access to the top and bottom of it. Sorry that I didn't have a better picture of hinges that are bad. I'm sure I have them, but that's actually what good welds look like on that thing. But be cautious with hinges. I don't recommend 3 hinges. You need to make sure that you got 2 hinges. They're properly aligned. And when you are testing for alignment, you're opening the gate all the way to the open position or past it, and all the way to the closed position or past it. And you need to make sure that there's no resistance specifically in that last part of the opening or the closing, because that's what's generally adding the most stress to the motor. There are a few scenarios where the motor gets stronger in one position than the other, but when you're using articulating arm like some of these commercial ones have, when it starts to get to the fully closed position or fully open, sometimes that's the most stress that the actual motor sees. So you need to make sure that hinges have the proper alignment and no resistance all the way open, all the way closed, or past that. There should be zero resistance. You should be able to walk up to the gate, slide or swing, push on it, and it should open or close. The largest doors in the world are opened by one person. So bomb blast doors and all that stuff, they're open and closed by one person because they have the appropriate hinges and they're balanced correctly. Stops, overkill on your physical stops. The weld thing goes back to what I was talking about before. Just overkill on your physical stops. If you think that a 1/4 inch piece of flat will do it, pull out 3/16, pull out a gate chain bracket, and weld that on there. It's better to just go overkill and know that it's going to last longer than not. Electrical ground rods, baby. If you're not recommending that your customer get ground rods, I think you're doing it wrong. And if you're shielding your wires on both sides and without the manufacturer specification, yeah, ground potential on one gate operator, different ground potential on the other one. Guess what you've done? You've just created voltage on the device that is supposed to drain voltage, the shield, or sometimes called the drain. And that's not what this caused. This is just probably too much current on one of the lines that came into it from a lightning strike, or possibly an electrician made a mistake or something like that and sent 240 to it, and or changing a panel and put the wrong breaker in it, or put the wrong voltage in it rather, and something got damaged. So that's all the fails that I got. This is Too Smooth Operators, the only show about that gate operator life, boy. It's the only show, only. And you just had another good show. Smooth